Hello everyone. So in the previous lecture, we have started the decoder component of transformer architecture. Before that, I want to do the revision of what we have studied in encoder. Okay, so this is your transformer architecture. All right, and in transformer, you are having two main components. One is encoder, another is decoder. Okay, so in these two components, like this is your encoder part and this is your decoder part. Fine. So we are going to give here input, and from here we are going to get the output. Encoder and decoder are connected like this. Okay, so we did studied encoder portion, and how the things went in encoder is we gave text as an input. The text is tokenized. We can say word piece tokenizer. Then we do have vocab formation, that is the integer representation of the tokens. Then we have performed word embeddings. We also calculated position embeddings. Okay, and we added both of them, word embedding plus position embeddings, and then we have given this as an input to encoder. So from here encoder starts. Okay, in encoder you are having multi-head attention. Okay, so from here you are having multi-head attention, where you say a head is a self attention mechanism. So you are having multiple self attention mechanism. Okay, so your input given to the encoder is divided. Your input is divided, that is your embeddings is divided into n q k v format. Okay, nqkv. Okay, so q is your query. Okay, it's a query. K is a key and v is value. And this qkv are used in self attention mechanism to find most important words in your text. That is what attention mechanism. That means we want to attend those words which will help me in creating the output. They are important in terms of context. They are important in terms of identifying relationship. They are important in order to produce a result. Okay, we do have the length of these vectors, that means good, or I would say more than in more than that, to RNNs, because in RNN we are having sequence length less, but here the sequence length is more. Sequence length or window is more. So the drawbacks of RNN are covered in transformer. Transformer, they are parallel. They can perform parallel processing. That is an issue in RNN. Okay, so right now we are in a better stage. Also in RNS there were no self attention mechanism. Later on we can add it. Okay, but the initial, the traditional architectures, they don't have self attention mechanism. Okay, so this QKV, what happens in multi-head self attention is Q dot key. We take the dot product of Q dot key K. Here we are getting attention scores. These attention scores are scaled or normalized. Scaled attention score. Then they are given to softmax so that their value should convert between 0 to 1. Okay, so first scaled and then given to softmax to convert the value between 0 to 1. And then this this attention scores are again perform the dot product with value. Okay, this AS updated will do the dot product with value, and you are getting the output. This is your attention mechanism. Fine. You can define Q as V1, V2. Okay, Q is V1 or V2 or whatever. So here, let us suppose Q is V1, and rest key will be V1, V2, V3. Value will also be V1, V2, V3, something like that. So first the dot product of these two, attention score, then these two steps you have to perform, and then whatever be the attention came, you have to perform the dot product with V. This is your self attention mechanism. And why this scaling and shortmax has been done? You could have asked a question, sir. If we are doing already shortmax, that will convert the values between 0 to 1, sir. What is the sense of doing the scaling first? See, the answers are been already published, and I gave you in the lectures also. There will be training, and in training gradients will be calculated. Okay, so for that particular reason we have to perform the gradient and all the calculations over scaled data, not unscaled. Shortmax is telling you how important a word is. Okay, which word is important by giving the score of probability. It's a probability. Okay, probability of the word which are important. That's what it is giving. So scaling needs to be done. Okay, scaling normalization are very much important. You are going to see this thing in each and every machine learning also, deep learning also, and generative AI also, everywhere. Scaling normalization, transformations. Okay, transformations, we can't skip from this particular step, because ultimately we are going to perform the gradient calculation. We don't want the fluctuations in the results. Okay, fluctuations, we are not expecting this. Okay, either vanishing gradient or exploding gradient. These two are the issues: vanishing and exploding. Okay, we don't want this thing. All right, in that particular case, you have to scale your data, transform your data. That's mandatory, necessary. So after getting the output from attention, we add this output with positional encoding again, and this is called as residual connection. Residual connection. Okay, fine. This will be your residual. Then again, you have to perform the normalization of the data. Again, perform the normalization of the data, the output which you are going to get from here by adding these two. You are going to perform the normalization. Then after the normalization, you are having linear layers. Okay, that is feed forward network, where you are having ReLU activation function also. ReLU. So after performing this thing, you are going to hand it over to the feed forward network, where you do perform point wise operations done. Okay, so linear layer with the ReLU. Okay, linear ReLU. So give this output from attention plus positional embeddings to form a residual connection that will be given to the normalization. Normalize it, then give to the linear plus ReLU. Okay, then again normalization, then linear plus ReLU, and so on. Linear ReLU, normalization, and so on. Okay, there are some series of layers present here. Okay, fine. From here, we are going to get the final result from encoder. Okay, you are going to get the result from encoder. Okay, which will be given next to the decoder, another component for text generation. Okay, text generation. So this is the input, that means which is produced by the encoder, is having attention mechanism in it and all normalized data. Okay, that means it is having information, relevant information. Okay, about the input, which has passed through all these layers of encoders. Okay, now I am sharing my entire screen. Though we have started the decoder, we will follow up the decoder again. Okay, so here it is, decoder. All right, so here is the decoder layer. Fine. So all these linear normalization are in a connection, and then we are getting the final result, and that result will be handed over to the decoder. Okay, so decoder job is to generate the text next sequences. Answer: decoder is also having the same layers like encoder. Okay, it is having multi-head attention too. It is performing point-wise feed forward. We also seen point-wise feed forward in encoder. Residual connection also. Normalization layer also. It is having all these things. All the sublayers are similar as done in the encoder except multi-head attention. Okay. Here the attention mechanism is a bit different from the encoder attention mechanism. Okay. Fine. Rest all are same. Because decoder job is different. The decoder job is to produce the answer for the input. Okay, now something which comes in our mind, sir, encoder components and decoder components are same, so we can expect multi-head attention, we can expect feed forward. These two we can expect normalization, everything we can expect in the decoder also. It is saying that decoder is capped off with a linear layer, acts as a classifier with a softmax function. Okay, linear layer. So we will be having some linear layers, and we will be having softmax function that will be act as a classification. Something we can expect. Here is your architecture. So this much part of encoder, multi-head attention, add a normalization, feed forward, add normalization. You can see here also. Same thing. You can see here also. Oh, one more thing, multi-head. It is having two multi-head as already given. So two multi-head and as like the encoder. So this is your encoder. This also seems to be like same sublayers like encoder, and this is your multi-head attention. Okay, multi-head attention. We whatever be the output which we got from the encoder, we supplied it to the decoder, to the multi-head attention. We supplied to it. Okay. Also, it is having this decoder is having outputs. It will produce the output, it will convert it into embedding, and it will give it to multi-head attention also. All right. So what decoder is taking as an input? What decoder is taking as an input? As an input, what it is taking? It is taking encoder output as an input. It is taking output, previous output from the decoder as an input, plus it is also taking start token. These three things it is taking as an input, decoder. So encoder, what we achieved, we are giving previous output also of whatever decoder produced, that also we are giving. Okay, initially it haven't produced anything, so just keep it as null. Also we are giving the start. So let us suppose the previous output will be the start. Will in the decoder the things get start from here. Okay, so start and then the rest of the tokens. All right. So decoder is called as auto regressive. Auto regressive means, sir, auto regressive. What is regression? What is regression? Regression, sir, we have studied in machine learning, sir, regression, where we perform predictions, sir, and the prediction of, sir, continuous variables, sir. For example, house price prediction, that's a regression problem, sir, where we find the price of a house, sir. Okay, so here also decoder is predicting something, and automatically it is predicting. So auto prediction. Okay, auto prediction. What it will be predicting automatically? Obviously, the words. Okay, I will be having the start token. Then the if you are asking a question to the transformer, hello, how are you? This is the question you ask, you gave input to the transformer. Transformer should answer, hi, I am fine. So with this input, transformer should identify what what word should come: high, then I, then M, then fine. So this is the prediction done by the decoder. What word should come next? That is why it is called as auto regressive. Okay. So it begins with the start token, and it takes a list of previous outputs as inputs. If there are, okay, after step one, you will getting the inputs from previous inputs you will be getting, as well as the encoder also. Encoder output I have already shown you here. Encoder output will be input to the decoder. Previous outputs also start it will take. So encoder already having attention information, that also I told you. Okay, the decoder stops decoding when it generates a token as an output. Okay, the decoder will stop decoding when it generates a token as an output. How? Can you please diagrammatically help us in understanding how things are going on? Now, just focus upon the input. Let us suppose this is what you have given as an input to the transformer. This is given to the encoder of the transformer. Hi, how are you? So can you thoroughly see the GIF working? All, see, initially all has been given as an input to the decoder. Okay, all has been given input to the decoder. Stop. Okay, all has been given. Hi, how are you? All has been given as an input to the decoder, along with start, and decoder has produced I as an output, one token at a time. And then this I will again, you can see here. So whatever be the output decoder generate, it will again given back as an input to the decoder to produce the next token. See, hmm. So I will be again given as an input. M is produced. M is again given as an input. Fine is produced. Fine is again given as an input. Nothing is produced because the answer is over. Okay, again check out how this works. Initially, all the inputs are given, then U, then R, then how, then high, and end. End token will be produced at the last after fine. This is how transformer decoder work. Okay, so just try to understand. Initially, all of this will be given along with the start. Okay, see, just by concentration what's happening. Okay, how the results are coming. Okay, let me clear the things to you again. Let's walk through the decoding steps. Before I want to read this line, decoder is auto regressive. It generates one token at a time. I told you, while being feed in the previous output. So one token at a time, one word at a time. That's what decoder produce. Okay, let's check out the steps. Decoder input embeddings and positional encoding. Again, without embedding, encoding, nothing can happen. Okay, So the beginning of the decoder is pretty much same as an encoder. Okay, the input goes through an embedding layer. So what are the inputs you gave? What are the inputs you gave to the decoder? You gave encoder output plus previous output plus start. So this will be given to the embedding first. Okay, embedding होगा इसका. Obviously positional embeddings या positional encoding will also be done. तो इनका embedding word embedding plus positional embedding ये दोनों होगा. Okay, that's what happened. Here you can check out. Okay. Hmm. So embedding layer, it will pass through the embedding layer and positional encoding layer to get the positional embeddings. Okay, embedding and positional encoding to get positional embeddings. Then positional embeddings are fed into multi-head attention, which computes the attention scores for the decoder input. Okay, so check the architecture again above. So outputs will be given to the output embedding. This is positional embedding, and this is given to the multi-head attention. Okay, multi-head attention. So whatever with the outputs decoder is creating, उसका embedding positional embedding सब निकाला जाएगा, and that will be given to the multi-head attention. And after passing through the multi-head attention, whatever be the normalization, everything will be done and it will be given to here. तो यहाँ पर ये encoder के साथ पैचअप कर लेगा. ओके, इतनी जो प्रोसेस है, लेट मी अगेन, जो आप समझ पाए. ओके, दिस मच प्रोसेस. ओके, अंडरस्टैंड. यू कैन सी हियर एनकोडर का आउटपुट तो यू टुक एंड यू गेव हियर. ठीक है, अब ये तो एनकोडर मल्टी हेड में इट विल बी गिवन, बट नॉट just only the encoder output will be given to multi head. Before that, whatever be the previous output of decoder, उसका embedding होगा, उसका positional embedding होगा, उस पर multi head attention mechanism will be applied and normalization everything will be applied, and then it will be feeded into the multi head along with the encoder, along with the start token. This will be done. Okay, fine. ये बताया जा रहा है यहाँ पर. तो डिकोडर का जो फर्स्ट मल्टी हेड अटेंशन है, द फर्स्ट मल्टी हेड अटेंशन, बिकॉज यू कैन सी टू मल्टी हेड. ओके, दिस इज फर्स्ट मल्टी हेड, दिस इज second multi head. Okay, this is second multi head. Okay, so it is having two multi head. So the first multi head operates slightly different. This multi-head operates slightly different. Since the decoder is auto-regressive and generates a sequence of word by word, you need to prevent it from conditioning to future tokens. इसका वर्किंग इंपॉर्टेंट है. IMP. ओके, IMP वाई? बिकॉज ऑटो रिग्रेसिव है, प्रिडिक्शन करना है इसे, नेक्स्ट वर्ड प्रिडिक्शन करना है इसे. This is the task of multi-head attention because decoder is auto-regressive. So you need to prevent it from conditioning to future tokens. आगे नेक्स्ट क्या टोकन आएंगे, नेक्स्ट टोकन्स व्हाट दे शुड बी, यू नीड टू प्रिवेंट इट और हाइड इट। यानी कि सीधी सीधी बात है, आपको यहाँ पर मास्किंग करना पड़ेगी। अच्छा, मास्किंग वाला कॉन्सेप्ट बर्ट में ऑल्सो आई टोल्ड, है ना, बोलते थे ना बर्ट में कि सर मेरे पास इफ आई एम हैविंग 100% डेटा, तो सर मैं 85% से ट्रेनिंग करूंगा, 15% मास्किंग कर दूंगा। इन बर्ट, बर्ट भी तो ट्रांसफॉर्मर ही है, बर्ट इज ऑल्सो ट्रांसफॉर्मर ना, बाय डायरेक्शनल एनकोडिंग रिप्रेजेंटेशन ट्रांसफॉर्मर। पढ़ी था अपन ने, मास्किंग करते हैं वहां पर, है ना, हाइड करते हैं। और ये अब रिस्पॉन्सिबिलिटी विल बी ऑफ माय ट्रांसफॉर्मर आर्किटेक्चर टू प्रिडिक्ट द नेक्स्ट वर्ड, ये उसकी जिम्मेदारी है कि तुम बताओ अगला वर्ड क्या होगा। उसी तरीके से नेक्स्ट वर्ड का मेरे को प्रिडिक्शन करना है, यहां पर मैं मास्किंग करूंगा। और मास्किंग जो है वो आपकी फर्स्ट मल्टी हेड अटेंशन मैकेनिज्म में होगी। ओके, एग्जांपल के तौर पे समझते हैं। व्हेन कंप्यूटिंग द अटेंशन स्कोर, मतलब आप देखिए अटेंशन स्कोर कंप्यूट, अटेंशन मैकेनिज्म में अटेंशन स्कोर विल बी कंप्यूटेड, व्हाट एल्स विल बी डन। जैसे कि on a word M, for example I am computing the attention score for M, you should not have to access the word fine। okay, ऐसा ही होगा when we will going to do the work from this token, I will be hiding that the next word will be I, and when I got the next word as I will be hiding the next word as M. When I'm going to get the next word as M, I am going to hide the next word as fine. And then the last is end token. Fine. Here is end. इन्हें हाइड करना है, ये तो मॉडल की रिस्पॉन्सिबिलिटी इन वर्ड को प्रिडिक्ट करना, तभी वो ऑटो रिग्रेसिव है। अच्छा सर, कुछ मैट्रिक्स वेट्रिक्स, ये लो, ये मैट्रिक्स। अच्छा, ऐसे ही जस्ट लाइक दिस ओनली यू क्रिएटेड, यू फाइंड द अटेंशन स्कोर्स। I hope if you remember this thing, you found the attention scores in encoder। See, check, ये check करो, है ना, you gave these as an inputs, and here you performed a dot product and then scaled and then performed the these are the scaled values। okay, after sort max they are converted between 0 to 1। सो ये आपको इसी तरीके से मैट्रिक्स बना था, तो अटेंशन में दिस थिंग हैपेंस। ओके, यही होता है। तो भाई वहां पर डिकोडर में भी अटेंशन में अरेंजमेंट इट विल डू लाइक दिस ओनली, बट वर्किंग अलग है उसका। द वर्किंग इज समहाउ डिफरेंट, दैट इट विल हाइड। ये देखो, ये रेड मार्क का मतलब हाइड ही है। स्टार्ट से वी आर गोइंग टू डू आई एम फाइन। एम को पता नहीं होना चाहिए कि नेक्स्ट वर्ड फाइन है। एम शुड नॉट नो व्हाट इज द नेक्स्ट वर्ड। ओके, अच्छा कैसे काम कर रहा है सर, कैसे, सी लिसन, ये कैसे मास्किंग वगैरह करोगे, हाउ यू आर गोइंग टू डू। A depiction of decoder's multi-head attention scaled attention score, the word M should not any value for the word fine। दिस इज ट्रू फॉर ऑल अदर वर्ड्स ऑल्सो। मैं आपको पहले ही बता चुका हूं ना, यहाँ पर ये तो अंग्रेजी में भी लिख रहा है, ये बताया तो था ये कि स्टार्ट के बाद आई आएगा, दिस शुड नॉट बी नोन। आई के बाद एम आएगा, दिस शुड नॉट बी नोन। देन फाइन, दिस शुड नॉट बी नोन। ओके, ये डिकोडर को आइडेंटिफाई करना है मैकेनिज्म में। ओके, we we need a method to prevent computing attention score of future words। ब्लॉक करो इस चीज को। We need a method to prevent, this method is called as masking। to prevent the decoder from looking at future tokens, you need to apply look ahead mask। This mask is added before calculating the softmax and after scaling the scores. कैसे ये लुक अहेड कैसे ऐड करोगे? चलो चेक करते हैं. The mask is a matrix that is having the same size as attention score filled with zeros and negative infinities. Okay, so we are having a mask matrix. Look ahead mask matrix that is filled with zero and infinity. And we are going to add the mask to the scaled attention score. We may get a matrix of scores with top right triangle filling with negative infinity. How? Check out. These are the scaled scores. We are going to add mask to it. This is upper triangle like. Okay, this is like upper triangle infinity. And these are the mask scores. So all these become infinity. Here also. Infinity, infinity, infinity. So scaled scores will be added with look ahead mask. Okay. We are going to study, understand, okay, one by one. The reason for masking is because you need to take the softmax of the masked scores. The negative infinity get 0, leaving 0 attention score for the future token. So if you take the softmax of this mask, okay, if you put this thing into the softmax, the next will be 0. Okay, fine. So in the figure, the attention score for M has values for itself and all the other words before it but is 0 for the word fine. If we come to M attention score is this thing. Before the word present M, its attention score is 0.31. Before it is 0.26. But fine का 0 है. This masking is different from how the attention scores are calculated in the first multi-head attention. This layer still has multiple heads that the mask is being applied to before getting concatenated and feed into the linear layer for further processing. The output of the first multi-head attention is mass output vector with information how the model should attend on the decoder input. Okay, because ये masking करने के बाद ये पूरा आगे मैथ्स लगेगा रेसिडुअल नेटवर्क जस्ट वहां पर था सेम आपको यहाँ देखने को मिलेगा. ओके, ठीक. तो ये जो डायग्राम है मल्टी हेड अटेंशन विद मास्किंग, ये रहा. इट्स लाइक सेम ओनली एज वी हैव सीन द अटेंशन मैकेनिज्म. इट्स लाइक सेम ओनली, बट मास्किंग से क्या होगा, वो नेक्स्ट वर्ड नहीं बता पाएगा. ओके, दिस विल हैपन. ओके, अब एक बार और इसको रिव्यू किया जाए और समझा जाए. ठीक, समझा जाए इसे. और input what you gave, understand, you gave this as an input, the encoder, previous output plus start, ये आपने दिया था इनपुट में. embedding, positional embedding will be done. Okay, embedding, positional embedding will be done. अच्छा, वेट अ मिनट, कुछ और बात। यहां पर जब ये स्टेप्स आ रही हैं, ये वी आर टॉकिंग अबाउट द फर्स्ट मल्टी हेड अटेंशन। ओके, पहले तो एम्बेडिंग, beginning of the decoder is pretty much same as the encoder. The input goes through an embedding layer and positional encoding are being built. The positional embeddings get fed into the first multi-head layer, which computes the attention score for the decoder input. हम्म, अब रुको जरा, यहां इस आर्किटेक्चर में, एज आई टोल्ड, लेट अस सपोज कि दिस इज योर फर्स्ट ऑटो एनकोडर, सॉरी, मल्टी, हाँ ये ऑटो एनकोडर नहीं, इसको मल्टी हेड अटेंशन कहते हैं। दिस इज अ फर्स्ट मल्टी हेड, दिस इज सेकंड मल्टी हेड, एज आई टोल्ड। ठीक है, ऐसा बोला था मैंने। अब शॉर्टमैक्स लीनियर आउटपुट प्रोबेबिलिटीज तो यहां से पास ऑन होने के बाद आ रही हैं। ठीक है, आप देखो, जस्ट अंडरस्टैंड, ये लुक अहेड करके, यहाँ ऐड करके, ये पूरा लाइक दिस बना के, क्या बोला, फर्दर प्रोसेसिंग के लिए लीनियर लेयर को दे दिया एंड आउटपुट इज ओके, मास्किंग करके ये सब पूरा दे दिया, फाइन, ये पूरा करके दे दिया, ये मास्किंग वाला था, करके दे दिया। सेकंड मल्टी हेड अटेंशन जो है पॉइंट वाइज फीड फॉरवर्ड, क्यू के वी, अगेन वो तो बनाते ही हैं, फॉर दिस लेयर द एनकोडर आउटपुट्स द क्वेरीज की and all values. This process matches the encoder's input of the decoder's input, allowing the decoder to decide which encoder relevant to focus. अब ये कहां आ रहा है, ये वाली बात, सेकंड, एंड लीनियर क्लासीफायर एंड फाइनल शॉर्टनेस फॉर आउटपुट द प्रोबेबिलिटी। तो भाई हम अपनी अप्रोच सही डिफाइन कर रहे हैं यहां पर, और सही चल रहे हैं, that this is your multi-head attention, this is your first, and this is your second multi-head attention. Whatever be the output you are going to get from here, you are giving forwarded to the next multi-head attention, that is the second multi-head attention. And still the phenomena is not yet over to understood. देखिए, अब डिकोडर को फिर और अपन अपने लेवल पर समझकर बनाते हैं। डिकोडर के लिए it has been told the decoder is having, the first step is embeddings, then the first multi-head attention, then all residual network, then second multi-head attention, then again residual network. Okay, these things will be present. Okay, and after that you will be having all linear, and all these things will be present in the residual, and then you are having your short max, ये होगा। ये डिकोडर का वर्किंग लग रहा है। आपको एम्बेडिंग करनी किसकी है, एम्बेडिंग किसकी करनी है, हुम, इनपुट की करनी है। इनपुट क्या आया, व्हाट इज द इनपुट गिवन टू द डिकोडर, व्हाट इज द इनपुट गिवन टू द डिकोडर, द इनपुट गिवन टू द डिकोडर एज आई मेंशन अबाउट, encoder output, previous output, and the start. That is what you have seen, that is what you have seen, कि आपको encoder output था hello how are you, ये इनपुट था। ठीक है, ये डिकोडर के अंदर जाएगा along with start, ये जाएगा। all these things will be given to the decoder, इसको 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 डिकोडर को दिया जाएगा, इसको भी दिया जाएगा इन फॉर्म ऑफ एम्बेडिंग्स। तो इनकी पोजिशनल एम्बेडिंग्स बनेगी वापस से, एंड इट विल बी गिवन टू द डिकोडर। ओके, एंड डिकोडर विल प्रोड्यूस अ टोकन I. After getting this, it will produce a token I. Okay. अब आई प्रोड्यूस करा सर, उसको मल्टी हेड जो आर्किटेक्चर था अभी आपने विच यू एक्सप्लेन्ड, थोड़ा सा इसको रिव्यू करके बताइए आप कैसे ये काम हो रहा है। ये यहां पर तो उसने बोला आउटपुट एम्बेडिंग, आउटपुट दैट इज शिफ्टेड, राइट, आउटपुट एम्बेडिंग, पोजिशनल एम्बेडिंग गिवन टू द मल्टी हेड and again given to the multi, there are two multi heads, their own phenomena। तो फर्स्ट वाला जो मल्टी हेड है वो मास्किंग कर रहा है, वो मास्किंग प्रोड्यूस कर रहा है, मास्किंग कर रहा है, ये अभी अपन ने समझा। ओके, और ये आपका ट्रांसफार्मर डिकोडर का वर्किंग, पहले ऑल द इनपुट हैज बीन गिवन, देन स्टार्ट, आई इज प्रोड्यूस्ड, देन यू आर हाउ, ओके जस्ट देखिएगा, पहले यू लाइट अप हुआ, यू, देन आर लाइट अप हुआ, देन हाउ लाइट अप हुआ, एंड देन हाई। होगा नहीं होगा वो लाइट अप नहीं बताया उन्होंने, हाई, बट हाउ आर यू। ओके, तो ये अटेंशन वाला इनपुट, ऑल आर गिवन एज एन अटेंशन स्कोर, ठीक है, ये इनपुट डिकोडर के अंदर गया along with the start, गया प्रीवियस इनपुट, प्रीवियस अभी कुछ है नहीं, तो लेट्स गेट स्टार्टेड विद दिस ओनली, ये गया, आई एम फाइन, these are the output produced, I am fine, these are the output produced। अब यदि सर यही आउटपुट प्रोड्यूस हो गया तो सर ऊपर तामझाम काहे करे फिर तुमने, यदि यही आउटपुट प्रोड्यूस हो गया तो ऊपर क्यों परेशान हो रहे हो फिर, ये कर दिया, ये तो डिकोडर से फाइनल आउटपुट की बात हो रही है, ठीक है। डिकोडर इज ऑटो रिग्रेसिव, इट जनरेट्स द वन एट अ टाइम व्हाइल बीइंग फेड इन द प्रीवियस वन, ये फाइनल आउटपुट हो रहा है, ये फाइनल मिलेगा, अभी पूरा खत्म नहीं हुआ था, यहां सब स्टार्टिंग हुई है। डिकोडर में पहले इनपुट एम्बेडिंग, पोजिशनल एम्बेडिंग कर दीजिए आप, फर्स्ट मल्टी हेड अटेंशन जो है वो ऑटो रिग्रेसिव एंड जनरेट द सीक्वेंस वर्ड बाय वर्ड, ये वर्ड बाय वर्ड जनरेट कर रहा है, ठीक है। यू नीड टू प्रिवेंट कंडीशनलिंग, फ्यूचर फ्यूचर वर्ड प्रिडिक्शन के लिए आपको रोकना पड़ेगा। तो पहले मल्टी हेड पर ये वाला जिस टास्क, और इसके लिए भी क्या करा उन्होंने, ये स्केल्ड स्कोर्स हैं, स्केल्ड स्कोर्स किसके हैं, whom scale scores are there, ये स्केल्ड स्कोर्स हैं स्टार्ट आई एम फाइन के। फिर वही क्वेश्चन सर, यदि ये बन गया, यदि ऑलरेडी आ गया था, ठीक है, यहीं पर ही, तो आपने डबल अटेंशन क्यों लगा रहे हो आप, व्हाट इज द रीजन फॉर डबल अटेंशन, एक ही बार में हो जाना चाहिए था यहाँ पर काम, डिकोडर को दिस पूरा सीक्वेंस दे दिया और एक एक करके वन बाय वन टोकन इट इज प्रोड्यूसिंग, तो बात खत्म हुई सर। लेकिन फिर आप ये हाइडिंग भी करवा रहे हो, इधर एक जगह बोल रहे हो कि हाइड कर लो आगे वाला वर्ड, तो प्रिडिक्ट करना ऑटो रिग्रेसिव है, आपने स्टार्ट दिया, आई नहीं पता था उसे, तो फिर आपने कुछ इस तरीके से टास्क परफॉर्म करा, आई इनपुट दिया, ठीक है, आई इनपुट दिया, फिर नेक्स्ट वर्ड आ गया, तो ये जो फिनोमिना है ये वाला कि आई इनपुट अगेन दोगे तो जाकर एम आएगा, एंड एम अगेन इनपुट दोगे तो फाइन आएगा, फाइन अलग वापस से इनपुट दोगे तो अब तो बात ही खत्म हो गई है, एंड आएगा, बस सीधा एंड, योर आंसर इज ओवर। ये लाने की प्रोसेस है वो, तभी उसको कहा गया कि द फर्स्ट अटेंशन इज एब्सोल्युटली डिफरेंट। तो ये लाने मतलब आई के बाद एम का पता नहीं होना चाहिए, क्या करूं मैं, हाउ आई शुड मेक द अटेंशन। इसलिए उसने कहा कि आई एम हैविंग अ मैट्रिक्स विद अटेंशन स्कोर, स्केल्ड अटेंशन स्कोर। इसमें मैं ऐसी मैट्रिक्स ऐड कर दूं जो जीरो और इंफिनिटी वाली है। ठीक है, ये अपर में इंफिनिटी 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 है। अब ये जब ऐड हो जाएगा तो ये सब इन्फिनिटी हो जाएंगे, ये इन्फिनिटी हो जाएंगे। अब फिर उसके बाद कहानी शुरू हो। डिकोडर का वर्क जबरदस्त है, क्योंकि ये ऑटो रिग्रेसिव एंड इट्स प्रोड्यूसिंग द आउटपुट। ठीक है, वन मोर लेक्चर आई रिक्वायर फॉर दिस ट्रांसफार्मर टू मेक यू एब्सोल्युटली क्लियर। एंटायर जो कॉन्सेप्ट है उसको क्लियर कर दूंगा। यस आदित्य।
सर ये अभी जैसे डिकोडर का जो भी